In this video, we're going to learn about a special class of ionic compounds called hydrates. So what are hydrates? Hydrates are ionic compounds that have water, or a hydrate, as part of their crystal structure. So let me show you an image of that before we go on to do some sample problems. So here we have a crystal, a blue crystal, and you'll notice it's copper sulfate, a copper 2 sulfate crystal there from the formula. And then there's a dot, and then there's 5 H2O. So that means that this copper sulfate has 5 H2O molecules embedded within the crystal structure in some way. And what you'll notice is that as you heat up this copper sulfate 5H2O structure here, it starts to change colors. It starts to go from blue to white. And so in this example here, the reason we're going from blue to white is because we're, as we heat up the copper sulfate with the water embedded in the particles, the water will evaporate from the particles, and then the crystals will be left white. And likewise, if you added water, it'll go back from white. It'll go back to blue from the white color that it turned. And so that's just because we're taking out the water from the crystal structure. The structure that contains the water is called the hydrate. And once you remove the water, you call it the anhydrous. So ionic compounds, you can call them salts. So we have a hydrate over here. And once you remove the water, it's an anhydrous salt. Or you can say, for example, this is copper sulfate hydrate, or hydrated copper sulfate. And here you can call this anhydrous copper sulfate, or copper 2 sulfate, I should say. So that's just a little illustration of what hydrates are. Hydrates aren't dissolving solids in water. You literally have water embedded in the crystal structure of the ionic compound. So in here we can see the ionic compound, then these little particles here, that's the water embedded within the crystal structure. If you look over here, we have copper 2 bromide, and then we have the little water particles embedded in the crystal structure of copper 2 bromide, the little red and white structures there, the H2O. Here we have chromium fluoride. And as you can see, we have the hydrated version here with the water particles embedded within. So visually, if you heated up a hydrate, you would often see it change colors, because you're getting rid of the water as you heat it up. So now what we're going to do is we're going to take a look at how to name the hydrates and how to write formulas for hydrates using a few ionic rules. So again, hydrates are compounds ionic compounds with water as part of their crystal structure. It's not dissolving. The water is part of the crystal structure. So it's not the same thing as a solution. So to write a formula for the hydrate, what you do is you first write the formula for the ionic compound that's in the name of the hydrate, and then you put a dot, and you write how many water molecules would be associated with that crystal. How do you know that? Well, you have to look at the prefix. You have to look at the Greek prefix. So these are the Greek prefix. This is the Greek prefix table here. So mono, di, tri, tetra, penta. So use a Greek prefix to indicate how much water you have. So for example, if I was doing tin 4 chloride pentahydrate, first I would find the formula for tin 4 chloride. And so using the crisscross, that would be SnCl4. Then I would put a dot, and it says here we have pentahydrate. So that means penta means 5. So 5H2O. And that there's tin 4 chloride pentahydrate. Let's try another one. We have calcium sulfate dihydrate. So the ionic compound, same type of formula rule that we saw earlier. Calcium sulfate, using your crisscross or charge balancing, is CaSO4. Put a dot because we know it's a hydrate. Di means that there's 2 H2O particles or molecules there. Now we'll try ferric hypochlorite heptahydrate. Oh, okay. So ferric, remember, is, I'm just going to do the work over here for this one because it's thinking here. Ferric is the highest charge of iron, which is iron 3. Ic is the highest charge. Hypochlorite. So remember that chlorate was chlorate is ClO3 minus, chlorite is ClO2 minus, hypochlorite is ClO minus. So ClO minus 1, crisscross, and we get FeClO3. This looks like chlorate, but it's not chlorate. Chlorate would have had the 3 inside the brackets right next to the O. This is outside. This means you have 3 hypochlorites. So let's write that out. We have Fe, open the brackets, ClO, close the brackets, 3, dot, heptahydrate. Hepta means 7, and then H2O. So that would be how you go from a name to a formula for a hydrate. And then we can go from a formula to a name for a hydrate. And it's really as simple as the only thing you're adding is how many water molecules you have attached to your ionic compound. So, for example, Na2S.4H2O. First, I'll name the ionic compound like I normally would. So sodium sulfide. Then I would say how many waters there are. So there's 4 waters. That's tetra. Tetra. Tetrahydrate. And again, you can pause the videos and try the ones below and then check your answers after. So here I have, I'm going to use both the stock and classicals to do this. So here I have copper to sulfate. Then 2 waters means dihydrate. And just to show you the or, if I was doing classical, this is a copper 2, so cupric sulfate, because SO4 sulfate, dihydrate. And then let's try to name this one here. So this is aluminum with a PO3 there. So this is aluminum phosphite. Aluminum phosphite. Then there's 6 waters, so it's hexahydrate. So naming and writing formulas for hydrate requires good knowledge of writing formulas and naming ionic compounds, because you're really doing the same thing. You're just adding an extra step of telling us how many water particles are attached or embedded within the crystal of the ionic compound. So again, it's not dissolving, it's actually water being part of the crystal of the ionic compounds. In your handout, you'll also see a few questions about the images that we discussed in the slides of this video. So you'll be asked some questions about this picture here and about this picture over here. And you can fill that out as you watch the video, or even just fill it out from memory and then go back and watch the video to make sure you're on the right track, just in case there were any misconceptions. And so that is how we name and write formulas for a special class of ionic compounds called the hydrates.